The aim was to manufacture a long-wave infrared heater in an additive manner. This part shows the resulting sintered two-component heating element made of insulating zirconia and electrical conductive stainless steel made by FFF. By connecting a power supply, the metal meander is heated up.
This study focuses on additive manufacturing with a multi-material approach to combine a metal with a technical ceramic. Combining these different materials offers a broad variety of applications due to their different electrical and mechanical properties. This combination can help to answer key questions in the medical, automotive, and aerospace fields. For that purpose, fused filament fabrication was selected. The main reason was the possibility to process different powders independently of their optical properties. Furthermore, the thermal post-processing is similar to well-established techniques such as powder injection molding, for which standard equipment is used. Fused filament fabrication becomes economical due to the high material efficiency and the recyclability of the materials. Finally, this technique is easy to upscale for larger parts since the process relies on a moving printing head on axis.
Before beginning the procedure, select a suitable powder couple for the multi-material approach. For the ceramic grade, select tetragonal yttria-stabilized zirconia due to the coefficient of thermal expansion and the sintering temperature being comparable to special stainless steels, as well as the high toughness and flexural strength of this ceramic material. For the specific metal grade, use stainless steel powder as the conductive and ductile metallic material due to its